Hi, everyone. This is the final segment of Lecture 18, in which we'll do a little bit of a deep dive on the prospects for life on Venus, the closest planet to us in the solar system in terms of size. So, Venus is often called Earth's evil twin because its basic characteristics are very similar to that of the Earth. It's only 95% the size of the Earth, so only about 5% different in terms of size. It's 81% the mass of the Earth, which is enough to give it basically the same composition. Venus has basically the same elemental makeup as the Earth. It receives only about twice as much light as Earth does. But despite that, it has a much, much hotter temperature on the surface. It's 700 Kelvin surface temperature, which is about 860 degrees Fahrenheit. And its atmosphere is about 90 times thicker than that of Earth and is mostly made of CO2. So, despite being so similar to Earth, it's a very unpleasant place for humans to be. The reason that Venus is so much hotter than Earth is because of the greenhouse effect. You may remember earlier in the semester when we talked about how the greenhouse effect keeps Earth warm enough for us to live comfortably. Without greenhouse gases in our atmosphere, Earth would be very cold and probably too cold to have liquid water. But because of the greenhouse effect, we're able to keep this warm, pleasant temperature that we're experiencing outside now that spring has come here to Madison. But on Venus, the greenhouse effect went into overdrive and essentially made it way too hot, so hot that there's no more water in liquid form on the surface, and basically has made it into an uninhabitable planet for human life. So, was Venus always like this? We think that probably Earth and Venus started off pretty similar to each other, given the other characteristic similarities between the two planets. So before the greenhouse effect ran away, it's possible that Venus could have been hospitable for life. So, like other locations in our solar system, in particular Mars, it's possible that early on, Venus was a good place for life to exist as well, but no longer has been the case since the climate changed so drastically there. But that doesn't necessarily mean that there's no life on Venus today. Even though the surface of Venus is hot and inhospitable, there are other locations, especially at higher layers in the atmosphere, that are more temperate. So, how could this be the case? Well, if you've ever seen images of snow-capped mountains, you can know that the weather higher in the atmosphere on a planet can be drastically different from the weather lower in the atmosphere. Here you can see warm palm trees in Los Angeles while you see these snow-covered mountains in the background. Clearly, there are some major differences in the temperature with just that small change in elevation between those two locations. You also can have lower pressures at higher altitudes. This is why if you've ever been on an airplane, your ears will pop. The lower pressure outside of the airplane and the lower pressure that they hold in the cabin of the airplane is enough to be noticeable by your body. So if you have less air pressure up there and you have lower temperatures, you can have a very different environment overall at higher elevations in the atmosphere than you can on the surface of a planet like Venus. And in fact, there are locations about 50 kilometers above the surface in Venus where the atmospheric pressure and the temperature are similar to the conditions on the surface of the Earth. So, if you have similar pressure and similar temperature, it's entirely possible that life could exist in the clouds of Venus at this altitude where things are a little bit more hospitable. So potentially you could even have like microbes sticking into water droplets elevated in clouds on Venus. So is this the case? Last year in September, there was a group of astronomers who argued that yes, this could be happening. So this is the paper. It says phosphine gas in the cloud decks of Venus, and it was widely reported by outlets including the New York Times, who think that who said life on Venus question mark astronomers see a signal in its clouds. So this was a very sensational story, and the scientific reasoning was fairly sound. What these astronomers did is they took observations of Venus with the ALMA observatory. This is the ALMA observatory here. These are these radio dishes that are in the southern desert of Chile, in the Atacama Desert, that are able to make very, very sensitive observations of light in millimeter wavelengths. So this is kind of microwave territory. And what they thought they were looking for, or what they found, was that they saw evidence that there is a molecule called phosphine in the cloud layers of Venus. Phosphine is a little bit of a strange molecule to find, though, because there's really no good way to form the amount of phosphine that they saw in their observations without having some sort of biological process. So, in their paper, they said the presence of phosphine is unexplained after an exhaustive study of different possible formation pathways. And because they couldn't figure out any other way to explain why this gas was there, they said that one possibility is that it could be coming from the presence of life in the cloud deck of Venus. So, as you can imagine, this was a really exciting moment for astronomers, and a lot of astronomers started checking out the data and seeing if they could find similar conclusions. So, one of the things that astronomers do, and scientists in general do, is when we see evidence for something very exciting, we start asking questions. We want to be really, really sure before we start to accept this as generally believed scientific dogma, basically. So, the two main questions about this story were: is the detection of phosphine robust? So, for example, if I took the same data set, would I draw the same conclusions about it from that data set? Is there really phosphine there, or are we being tricked somehow? And the other question is, okay, if there is phosphine there, is there something that could be producing it other than life? Is there some other explanation for why we see more phosphine in Venus's atmosphere than we would have expected to, just based on the chemistry that we think is going on? So, when a scientist started asking these questions, actually some problems started popping up. And a series of papers released since this first one have concluded that there may actually not be any evidence for phosphine in these observations. It's a really challenging observation to make, and it's a new instrument. ALMA was just commissioned a few years ago, and they're still trying to figure out the best way to observe all sorts of different objects. Venus is a particularly challenging object to look at because it's so close and so bright that it makes it a little bit different from most of the other fainter astronomical objects that ALMA spends a lot of time observing. So all of these reasons put together have cast quite a bit of doubt on whether or not the detection of phosphine in the atmosphere of Venus was actually real. And I think that if you ask a lot of astronomers right now, they would probably say odds are there is no phosphine detection, or at least certainly not what the original claim was. So it may be the case that there's just nothing there at all, and this was all just a false alarm. But I want you to take away a few things from this story. Number one, this is science in action. This is how scientists actually work to try to understand what's going on in our universe and try to figure out if a real discovery is actually true. So it's not a failure on anyone's part. This is just how it goes. And sometimes you get tricked as a scientist, and that's what the rest of the scientific community is there to do, is to try to confirm or refute what you're doing. And the second takeaway is that remote sensing is hard. Remember earlier in this lecture, I talked about the trade-offs between remote sensing and going to a place in situ. In this case, we only had remote sensing observations of Venus. If we were able to send a spacecraft there, it would be much easier to tell definitively if that phosphine detection really is real. So this is an example of a case where in the future, we could pretty easily send a spacecraft to Venus. Of course, it would be expensive, but it's within the realm of possibility, and we've done it before. If we found a similar signal around a planet outside of our solar system, it would be essentially impossible to get that corroborating evidence, and it would be much more difficult to make a firm claim about whether or not there is life on this other planet. So this could be a word of caution for trying to find life outside of the solar system. It'll be really hard to be 100% confident in your discovery, and there may be ambiguities that just aren't resolved for many, many years.